channel Maths and Methods Academy. Today we are going to verify trigonometric identities. So let's go for it. Our first question related to this is secant theta plus 1 over secant theta minus 1 under square root is equal to secant theta plus 1 over tangent theta. Okay, in this question our left hand side is secant theta plus 1 over secant theta minus 1 under square root. We will multiply and divide by secant theta. So secant theta plus 1 into secant theta plus 1 over secant theta minus 1 into secant theta plus 1 whole under square root. In the numerator now we have both the same expression, so it will become a square of secant theta plus 1 whole squared, and in the denominator we have this type of formula: a minus b into a plus b is equal to a squared minus b squared. So in the denominator we will write secant theta square minus 1 squared Okay, now we will keep the numerator as it is, secant theta plus 1 whole squared over secant theta square can be written as secant square theta minus 1 whole under root. And if you can recall the identity, 1 plus tangent square theta is equal to secant square theta. So if we subtract 1 from both sides, we will be getting tangent square theta is equal to secant square theta minus 1. And we have here in the denominator secant square theta minus 1, which we can replace with tangent square theta. So we will go and replace it there. Tangent square theta and we can write it like secant theta plus 1 over tangent theta whole square and then under root. Square will cancel with under root, so we are getting secant theta plus 1 over tangent theta, which is equal to the right hand side and as required. Now we move on to our second question. Our second question is 1 plus cos theta over 1 minus cos theta under square root is equal to sin theta over 1 minus cos theta. Our left hand side in this case is 1 plus cos theta over 1 minus cos theta whole under square root. We will multiply numerator and denominator with 1 minus cos theta. In the numerator we have this type of formula now: a plus b into a minus b is equal to a squared minus b squared. So we will be writing numerator as 1 squared minus cos theta squared over 1 minus cos theta squared whole under root. Numerator can be written as 1 minus cos squared theta over 1 minus cos theta whole squared under root. Now we again recall the identity over here. The identity is sine squared theta plus cos squared theta is equal to 1. If we subtract cos squared theta from both sides, we get sine squared theta is equal to 1 minus cos squared theta. So here in our expression we will replace 1 minus cos squared theta with sine squared theta. Okay, now we can also write it like sine theta over 1 minus cos theta whole squared and then under square root. Square root will cancel with square, so we will be left with sine theta over 1 minus cos theta, which is equal to right hand side and as required. Let's move on to our third question, which is the last one in this. Cos 4 theta minus sin 4 theta is equal to cos square theta minus sin square theta. Left hand side of this question is cos 4 theta minus sin 4 theta. We can write it like cos theta raised to power 4 minus sin theta raised to power 4 equals cos theta square minus sin theta square of square. Here again we have this situation, or one more step will be there, like we can write cos square theta square minus sin square theta square. So this is again like a formula: a squared minus b squared is equal to a plus b into a minus b. So using this formula we can write cos square theta plus sin square theta into cos square theta minus sin square theta. Here we can recall the identity cos square theta plus sin square theta is equal to 1. So we can replace this one with 1. So 1 into cos square theta minus sin square theta. 1 multiplied by anything is the same expression, so it will come out to be cos square theta minus sin square theta, which is equal to right hand side and as required. That's all for now. Please subscribe this channel, and until the next time, take care and bye.